Hey guys. All right, so day one, I tried to use Google Meet to create the video. I think it was pretty easy to access, but I didn't think the picture quality was very good. So in yesterday's video, I just used the camera on the computer, which I thought the video quality was better, but I know it took a long time to upload, and then I think in turn took a long time for you to download. So I apologize, and I think some people even had trouble downloading it. So today I'm going to try to create a YouTube video and see how that goes. So I can use my tablet and the video picture is much better. All right. All right, so we're going to be starting lesson 10.2 today. Okay, I will upload a blank copy of the notes along with my my answer key so that you can fill it out and have it in your notebook if you find that helpful. I'm going to read a lot of this to you because it would take me a long time to write all the word problems out and write all the definitions out, but I'll work the problems out on the board, okay? This is a 2-day lesson, so I'm going to give you, I think, 3 examples today, and then we'll do some more practice problems together tomorrow, and you will have an assignment tonight and tomorrow night related to 10.2, so make sure you log on to the textbook and do that. Please keep emailing me if you have questions or issues. Also, feedback about the quality of the videos, what you're finding easy, what you're finding hard, so we can try to figure out what works for everyone. And yeah, keep me in the loop. Also, keep in mind, I'm working from 9 to 1, but then after 1, I have to go back to family life. So if I don't respond to your emails until the next morning, just, hang out. I can't always get to them at 6, 7, 8, 9, 10 o'clock at night when you guys decide to log on and do your work. All right. So, vocabulary, independent events. So 2 events in which the occurrence of one event doesn't affect the occurrence of the other event. Okay. And we're going to talk about, are these 2 events dependent? Does it matter what happens the first time? Is that going to influence what's going to happen the second time? All right, dependent events, and I'll give you examples of both. Dependent events, 2 events in which the occurrence of one event does affect the occurrence of the other. So in this type of example, we'll talk a lot about like selecting teams, and if we pick one person for a team, well then when you go to pick a second person, you have one less person to choose from. So that would be an example of a dependent event, okay? Conditional probability. The probability that event B occurs given that event A has occurred, and it's written as P, the probability B given A. Okay, so again, it's the probability that event B occurs given that A has occurred. Okay, and that's the way we write the notation. I think I wrote that right where there's a glare. All right. So, in your notes, it also talks about probability of independent events. Okay, 2 events, A and B, are independent if and only if the probability of both events occur. Sorry, if the probability that both events occur.
I didn't do anything.
It's okay. You dropped your water. Sorry, guys. We're back. We're back. All right, step out in the other room, please, so that doesn't happen again. Okay, we're all good. We're all good. All right, so let me start that again. Probability of independent events. 2 events, A and B, are independent events if and only if the probability that both events occurs is the product of the probabilities of the events, okay? And we're going to look at an example of that just in a moment. Okay, so the first example that's written in my notes, it says this. A student taking a quiz randomly guesses the answer to 4 true-false questions. And then we want to use a sample space to determine whether guessing question 1 correctly and guessing question 2 correctly are independent events. So you probably can think logically about this, right? If you select true or false for the first answer, does that have anything to do with your selection of your second answer? And you can probably identify it as independent or dependent without going through what we're going to go through, but I want to show how to work it out using sample space, okay? So I am going to ask you to think about it logically first. So in my notes, what I wrote was, does the occurrence of one event affect the other. Okay, so when you select true or false for your first answer, does that have anything to do with your selection of the second answer? And hopefully we also would say no. Okay, the answer here is no. So that means that they're independent events. Okay, so we want to talk about the sample space. You want to list out the sample space, and then we'll talk about the probability of guessing question 1 correct and guessing question 2 correct. Okay, so, and again, you probably can just think logically about the probabilities. So for your sample space, I'm going to be using I's and C's for incorrect and correct. You could use T's and F's for true and false, whatever you want. So you could guess that all 4 are incorrect. You could guess that all 4 are correct, right? You could guess that the first one is correct and the last 3 are incorrect. You could say correct, incorrect, correct, incorrect. We could say, what else did I have? Incorrect, correct, incorrect, incorrect. You could have incorrect, incorrect, correct, incorrect. You could have incorrect, 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 correct. All right, this one's kind of out of place. I should put this one actually over in my next column. So I kind of follow a pattern, right? C in the first spot, second spot, third spot, fourth spot. All right, so imagine that this one is over here. I have correct, correct, incorrect, incorrect, and then I'd actually have this one listed, and then I would have correct, incorrect, incorrect, correct. Just want to make sure I don't miss any of them. I would have incorrect, correct, correct, incorrect, incorrect, correct, incorrect, correct, incorrect, incorrect, correct, correct. And then first one incorrect, all 3 correct. And then we'll just move the I 1 spot. Okay. So we can also calculate how many should be in our sample space by using that fundamental counting principle. Okay. First question that you answer, 2 options. You're either going to choose correct or incorrect, true or false. Again, second question, you still have 2 options, correct or incorrect. Again, that's why they're independent events, because what you select for the first answer has nothing to do with your second answer. And then the third question, again, you still have 2 options. And the fourth question, 2 options, okay? So 2 times 2 is 4, times 2 is 8, times 2 is 16. Let's make sure I have them all listed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, so I have all 16 options listed. Okay, so now we're going to talk about the probability. You can still see, yep. The probability of correct on question 1. Q1 correct. Okay, so again, you could probably think logically about this. If you're going to answer question 1 either correct or incorrect, the probability of answering it correct is going to be 1 out of 2, right? Or you could use your sample space and count how many different times was question 1 answered correct with a C. So it's 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 16. So again, you could say 8 out of 16 times if you're using your sample space, which simplifies down to 1 over 2, or using logic, if you have 2 choices, correct or incorrect, then the probability of choosing correct for question 1 is going to be 1/2, right? You have 50-50 shot, okay? And then the probability question 2 getting correct, again, using logic, I'm sure you'd say 50%, 1/2, but you can also go through. So here I have question 2 correct. That's 1, 2, 3, 4, 5, 6, 7, 8 out of 16 again to get 1/2. Okay. Now, the directions, I know I didn't write them up on the board. It says, use a sample space to determine whether guessing question 1 and question 2 are correctly are independent events. So above, where we talked about independent events, the probability of A and B is equal to the probability of A times the probability of B. Okay, so that's what we're going to show next. All right, so the probability that you're going to get Q1 and Q2 correct. All right, so we can again count, or if you multiply what's 1/2 times 1/2, you're going to get 1/4, but let's count and use our sample space. So Q1 and Q2 correct. So I'm going to go through. Here's one spot where I have them both correct. So 1, 2, 3, 4. 4 out of 16. 4 out of 16, which simplifies down to 1/4. Okay, and that 1/4 I could also get by multiplying these two together, which shows that they are independent events. All right, so that is example 1. Let me erase it and get it up for example 2. Okay. So for example 2, it says a group of 4 students includes 1 boy and 3 girls. The teacher randomly selects one of the students to be the speaker and a different student to be the recorder. Use a sample space to determine whether randomly selecting a girl first and randomly selecting a girl second are independent events. Okay, so I'm going to start by saying the same thing. Does the occurrence of one event affect the other? So you have to think in terms of this problem. Selecting the first person who is going to be the speaker, and then selecting the second person who's going to be the recorder, are they independent or dependent events? Okay, so since they have specific roles, and since after selecting the first student, you have one less student to select for the second part, right? After you select your speaker, you don't have that student to choose from to be your recorder. So they're dependent events, right? The one does affect the outcome of the other. So they're not independent, they're dependent, okay? We are going to list our sample space like we did for the last problem. So for the sample space, remember we have, how many girls again? We have 3 girls and a boy. So you could pick, I'm going to call them girl 1, the first girl and then the boy. You could pick the second girl and the boy. You could pick the third girl and then the boy. You could pick the first girl and the second girl, the first girl and the third girl, the second girl and the third girl. You could pick the boy and girl 1, the boy and girl 2, the boy and girl 3. Now, these are different because they have specific roles. It would be, what was it again? Speaker recorder versus speaker recorder. So the boy would be the recorder here, but the speaker there. That's why they're different events. All right, keep going down with your list. It could be girl 2 and girl 1, girl 3 and girl 1, girl 3 and girl 2. And you can again use the fundamental counting principle, right? The first person that you're going to select is going to be the speaker, and you have 4 people that you could choose from. You have the 3 girls and the 1 boy. The second person is going to be the recorder. Well, you only have 3 people to choose from because 1 person was already selected, so you have 1 less person. Multiply together, it's 12. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in our sample space. That's good. We did our sample space correctly. We didn't miss anyone. All right. So now that we have our sample space, we're going to look at the probabilities. Okay, so the first thing we're going to look at is what's the probability of girl first. Okay, so out of the 12, how many times is a girl chosen first? 1, 2, 3, 4, 5, 6, 7, 8, 9 out of the 12. 9 out of 12. So that simplifies down to 3/4. Okay? And then what's the probability that a girl is going to be chosen second? So I go through 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 12 again, which simplifies down to 3/4. Okay. Now they want to know what's the probability that a girl's chosen first and second. Probability girl first and second. So let's see. No. 1, 2, 3. No. 4, 5, 6. That's 6 out of 12. And that's 1/2. Now, if these were independent events like the last example, these two would multiply to be the same as this one over here, the 1/2. Okay, but 3/4 times 3/4 is equal to 9/12, which is not 1/2. So that's showing that they are not independent events, that they are dependent events. Okay?
Where's my water?
I don't know. Not sure. All right, so we have one last example. Oh, wait, I think I need this for, yeah, I do, sorry. Okay, so on the next page, before I erase that, on the next page, it talks about probability of dependent events, and it refers back to this problem, okay? So it says probability of dependent events. If two events A and B are dependent events, then the probability that both events occurs is the product of the probability that the first event of the first event and the conditional probability of the second event given the first event. So we're going to talk about conditional probability for just a second, referring back to this, okay? So I said that these are dependent events. We kind of hopefully understand that the occurrence of one does affect the other. And we can see that the 9/12 is, or the 3/4 if you want to simplify it down. I don't know how to multiply. That's not 9/12, it's 9/16. Oh my goodness. Sorry guys. 9/16. Still not equal to 1/2, but I want to make sure my math is right. Okay, so if you continue to look with me though here, because this is where I'm looking now. Okay, so it says probability of girl first and girl second is equal to the probability of a girl first times the probability of a girl second given that a girl is chosen first. Okay, and if you follow along with the math, I'm just going to point here, okay, to the board. So it says the probability that a girl is chosen first. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 out of the 12. So that's where that 9/12 comes from. All right, and then this notation, the probability that a girl is selected second, given that a girl is selected first. So I'm going to look for where a girl is selected first, and then where a girl is also selected second. So that's 1, 2, 3, 4, 5, 6 out of the 12 times. That's where that comes from. Okay, so multiplied together is where the 1/2 comes from. All right, which is what we got here, but not really using the definition to get it. Okay, so the last example. Okay, so it says, as part of a board game, you need to spin a spinner which is divided into equal parts. Find the probability that you get a 5 on your first spin and a number greater than 3 on your second spin. And our spinner is divided into, it says equal parts, but if you look at my diagram, it's 8 equal parts because that's kind of important. Okay, so you have this spinner. One, 2, 3, 4, 5, 6, 7, 8 equal parts. Again, it says find the probability that you get a 5 on your first spin and a number greater than 3 on your second spin. So first off, are they independent or dependent events? Does your first spin have anything to do? Is it going to influence? Is it going to impact your second spin? No. So they are independent events. Okay. So the probability that you're going to get a 5 on first spin, well, it's favorable, what you want the 5 out of all the total, so it's 5 out of 8. Oh, no, it's not. Sorry, not 5 out of 8. You want a 5, but that's only one spot, right? It's one spot that you want out of 8 total spots it can land on. So 1 out of 8. Okay? And then it says, what's the probability of getting a number greater than 3 for your second spin? So the probability of, I think I just wrote greater than 3. Well, how many spots are greater than 3? 1, 2, 3, 4, 5 out of 8. Maybe that's why I was thinking 5 out of 8 for a second. All right, 5 out of 8. Okay, so find the probability that you get a 5 on your first spin and a number greater than 3 on your second spin. So probability 5 on first and greater than 3 on second. So since they are independent events, you take these two and multiply them together. Okay, that's based on the definition from the previous page. So it's 1/8 times 5/8, which is going to give you 5/64. And you can leave that as your answer, or maybe you give me a decimal approximation if the directions ask you to, of 0.078, or move the decimal 2 places and give me 7.8%. Okay. All right, guys, that is it for today. Go ahead and give your homework a shot. I will post it on the textbook, and then we'll do more practice with this lesson tomorrow. All right, bye.